This is a question on gas laws, the general gas law, which is also referred to as the combined gas law. That is, it has to do with the application of both Boyle's law and Charles' law. To attempt this question, we'll be using the formula, that is the formula of the general gas law, which is P1V1 over T1 equals P2 V2 T2. So having written the formula, the next step is to write out the values for each of the variable present. When I say variable, I mean the letters P, V, and T. Let's start with the first one, P1, that is the initial pressure of the gas. So P1 equals 0.971 atmosphere. Then V1, that is the initial volume of the gas, that's 146 cm3. Then T1 now, the initial temperature of the gas, that's 18 degrees Celsius. So we'll be converting this to Kelvin by adding 273, which is equivalent to 291. That's for the initial values. Now for the final values, now we have to make to understand that the volume is to be determined in standard temperature and pressure, that is s.t.p. So at s.t.p now, which is the final pressure of the gas, that's P2. At s.t.p, pressure is 1 atmosphere, so we have 1 atmosphere. Then the volume V2 is unknown. So for the final temperature at s.t.p, the temperature is 0 degrees Celsius, which is equivalent to 273 in the unit Kelvin. How do I get to 273? That is, I added 273 to the value when converting from Celsius to Kelvin. Now we've gotten the values for the variables and we identified our unknown to be V2. So to continue, the next step now is to make V2 the subject. So we'll be saying V2 from the formula written above, V2 equals P1, that is, we'll cross multiply V1 T2 divided by P2 T1. So let's substitute the values. V2 equals P1, that's 0.971 atmosphere, multiplied by V1, which is 146 cm3, multiplied by T2, 273 Kelvin, divided by P2, which is 1 atmosphere, multiplied by T1, which is 291 Kelvin. Calculating this, we have 133 in our unit centimeter cube, which should be serving as the final answer. We've come to the end of the solution to the question, and we've gotten the volume of the gas to be 133 cm3. That will be all. Don't forget to subscribe for more if you find this video helpful.